We are continuing with our look at linear equations, and now we're going into linear equations in two variables. And so we have the equation here, 2x minus 5y equals 11. And this is an example of a relation. And I say a relation because there is two variables and there's going to be a relationship between the values of x and the values of y. And so we're given some questions here that ask us, are these particular points that are given to us solutions? Notice how in parentheses for the first question, you have parentheses -7 comma -5, close parentheses. That gives us our value for x and our value for y. So if I input these values, does it give me a true statement? Right? Does it fit the relationship as defined by this equation? So that's solved similarly the way we were doing it before, in terms of you can just substitute into the equation. And so I have 2, and I'm going to substitute for x, -7, minus 5, and I'm going to substitute for y, -5. And I'm going to check to see if that equals 11. So let's continue to evaluate this. We get -14 and then plus 25. -14 plus 25 equals 11. So we do get a true statement. This is true. Let's try the next one. For 3 comma -1. Again, 3 is x, -1 is y. So we have 2 parentheses 3 minus 5 parentheses -1. And we'll see if that equals 11. Let's continue to simplify. We get 6 plus 5, and that equals 11. So again, we get a true statement. So 3 comma -1 is a solution. It fits the criteria for this equation. We get a true statement. Let's continue. -9 comma 4. Okay, is that going to work? So we have 2 parentheses -9 minus 5 parentheses 4. Let's continue to evaluate that. We get -18 minus 20, and that equals -38. No, that does not give us a true statement. It doesn't fit the relationship as we've defined it. So that is not a solution. All right, and then our last example, we have 4 comma 2. Go ahead and pause the video and evaluate that on your own, and then we'll do it together. Okay, so let's try it. We have 2 parentheses 4 minus 5 parentheses 2. So that gives us 8 minus 10, which equals -2. So no, that is not giving us a true statement based on how it was defined. Okay, so obviously we can have really infinitely many solutions for this two-variable linear equation. And so here we have a question. Find another ordered pair that is a solution to the equation, right? So we were given ordered pairs earlier, and we were asked to determine if those were solutions. But how do we find an ordered pair that is a solution to the equation? So again, we have the equation 2x plus 5y equals 11. Well, since there's infinitely many, and I know this is going to be, if I graph this, it's actually going to be a line. I know there's infinitely many points on the line, so I'm not worried about finding one because there's a lot of them, but let's pick a value for x. How about, we'll say 2. And so we have 2 times 2 plus 5y equals 11. So if I continue to solve this, I get 4 plus 5y equals 11. Continue to solve for y by subtracting 4 on each side, minus 4 minus 4. So we get 5y equals 11 minus 4 is 7. And then divide both sides by 5. So we get y equals 7/5. So our ordered pair is 2, 7/5. This is a solution. This is a solution to the equation that we were given in the beginning. So you can find any solution by picking one of the variables and calculating the other. So considering that, this takes us into graphing. When you are graphing, the most basic method for graphing a line is to simply plot a few points, then draw a straight line through the points. You need at least 2 points. So in order to graph, you need solutions to this equation. So we need to pick a value for x or y. Generally, I'll pick values for x and then calculate y, but it's not required. You can pick a value for y and then calculate x. So I like to pick 0 for x for at least one of my points because it's easy to calculate with 0. So we have y equals negative 2x. If I write y equal to negative 2 times 0, I can see y equals 0. So when x is 0, y is 0. That is one point, one ordered pair that is a solution for this graph. Let's find another one. How about 2? All right, so if I do y equals negative 2 times 2, that gives me negative 4. So y is negative 4. So when x is 2, y is negative 4. I only need 2, but I'm going to do one more just for good measure. How about we do something negative for x? How about negative 3? So we have y equals negative 2 times negative 3, and that gives us 6. Okay, now let's plot these points on our graph. Prior to this, we were graphing on a line. Now we're in a rectangular grid. We're graphing in 2 dimensions. And so we have really, it's like having 2 number lines. One's horizontal and one's vertical. The horizontal line, we call that our x-axis. The vertical line, we call that our y-axis. And the point where they intersect is called the origin. And that's where we're going to start from whenever we start our graphing. So in fact, one of our points is at the origin, 0, 0. The origin is 0, 0. Okay, so this is the origin. Okay, now the next point says 2, negative 4. That means x is 2, so I would start at the origin and I would count 2 units to the right, 1, 2, and then negative 4 means I count 4 units down, 1, 2, 3, 4, and I plot a point. So there's the point 2, negative 4, And then again, back to the origin, we're going to plot the point -3, 6. So we're counting 3 to the left, 1, 2, 3. And then for 6, that goes 6 up. 1, 2, 3, 4, 5, 6. That point is -3, 6. And now let's draw a line for our graph. All right, that's perfect. Make sure you put arrows on the end of your line to show that it's continuing infinitely in both directions. And there you have it. Notice you only needed 2 points, but I used 3. And all those points should fit perfectly on the line. If they don't, a mistake has been made. Now, once you make your graph, these points that you plotted were there for you to draw the graph of the line. The line then represents all the solutions to this equation, right? As defined by y equals -2x. Okay, let's try another one. We have the equation y equals -2x minus 3. And again, we're going to use the method of point plotting. So we're going to plot a few points. So we have, let's start with 0 again for x, because again, it's easy. So we have y equals -2 times 0 minus 3. So that gives us y is equal to -3. Let's go ahead and plot that point. So starting at the origin, which is 0, 0, x is 0, so we don't need to go right or left. Y is -3, so we need to go down 3. 1, 2, 3. Plot the point. Okay. All right. We need at least one more point, but I'm going to do more than one more. So why don't we do, let's do 2. Why not? So we have y equals -2 times 2 minus 3. So that gives us -4 minus 3. And -4 minus 3 is -7. So that means x is 2, y is -7. Let's plot that point. So starting from the origin, if x is 2, we need to go right 2 units, 1, 2, and we need to go down 7 units. 1, 2, 3, 4, 5, 6, 7. Plot the point. Now we can draw our line now, but I want you to do one more point, and I'll give it to you. Why don't we do x is -3? Go ahead and pause the video, calculate the y value, and then plot it, and we'll do it together. Okay, so we have y equals -2 times -3 minus 3. So that equals 6 minus 3, and therefore y is 3. So to plot that point, we start at the origin, and we go left 3 units, 1, 2, 3, and then go up 3 units, 1, 2, 3, and then we plot our point right there. There's our third point. Okay, let's draw our line. Again, make sure you put arrows on both ends of your line, and don't be stingy with the graph. Draw your line so it's going through the entire rectangular grid that you've provided yourself with, not these short little stubby lines as if you're running out of lead. Okay, you see how my line is taking up the entire graph? Do that. Okay, so here we go. So now this line has infinitely many points, right? So this represents all of our points. And this is the graph of the line y equals -2x minus 3. It shows the relationship as it exists with all of the x and y values. Okay, now we have an equation that is y equals 1/5 x minus 2. So again, I like to use the value 0. So go ahead and find that and we'll do it together. All right, so let's see, we have y equals 1/5 times 0 minus 2. So that gives us y equals -2. Okay, now because of the fraction and because we're graphing by hand, we want to be clever with the value we pick for x. Okay, let me show you what would not be clever if we picked like 2. This is not clever. So when I go to calculate my y value, I do y equals 1/5 times 2 minus 2, which is going to give me 2/5 minus 2. And I am not liking what's coming about for my y value. Okay, so I'm going to get a fraction, and in fact, that fraction is going to be -1 3/5. Okay, if you write it as a mixed number, it will be -8/5. And I don't like having to graph that particular number by hand. You can, but it's just not friendly. If you're graphing using software or computer, then it doesn't really make a difference. But by hand, don't love it. So what would be clever is if we picked an x value that is a multiple of 5. Since our denominator is 5, it's going to get rid of the fraction when we do our calculation. So why don't we pick x equal to 5? So when we do that calculation, we have y equals 1/5 times 5 minus 2, which gives us 1/5 times 5 is 1 minus 2, and that gives us -1. And why don't we do one more? This time we'll do let's do -10. Okay, so we have y equals 1/5 times -10 minus 2. All right, so 1/5 times -10 is -2 minus 2, and -2 minus 2 is -4. Okay, so I'm going to plot the first point we found in the last two, not the one with the fraction. So we have x, y. All right, so starting from our origin, we have 0, -2. So we go down 2, that's our first point, back to the origin. 5, -1. That means we go to the right 5, 1, 2, 3, 4, 5, down 1. And then last point, -10, -4. That means we go to the left -10 and down 1, 2, 3, 4. Okay, let's draw our line in. All righty. Again, make sure you put arrows on both ends of your line. Don't be stingy with the graph. Okay. All right, there's the graph of our line. All right, let's take a look at some special cases where we have horizontal and vertical lines. So consider the equation y equals 3 and what that means in words. So if we were just in one dimension, we would just put a point at 3. But because we're in 2 dimensions, we want to consider all of the places where the y coordinate is always 3, right? So this is a line with the height of 3, and it's going to be horizontal. Now, how does this relate to point plotting. Let's think about this. We have y equals 3. I'm going to draw my table and put my x and y values and think about if x is 0, y is 3. If x were 2, y would still be 3. If x were -4, y would still be 3. All of these points fit the criteria for the equation y equals 3 in 2 dimensions, right? So let's plot these points, okay? So we have, starting at our origin, we would go up 3, plot a point. All right, back to the origin for 2, 3, go right 2, up 3, plot a point. Back to the origin for -4, 3, go left 4, 1, 2, 3, 4, up 3, plot a point. And let's draw our line in. Okay, so there is our graph for the equation y equals 3. Every point along this horizontal line, the y coordinate is 3. Now the x coordinate can change, but this fits the bill for y equals 3 in 2 dimensions. Analogous to that, oops. Oh, there we go. I'm sorry, I have to scroll down a little bit. There we are. What if we had x equal to -6, right? This is similar where if you were in 1 dimension, we would just plot a point at -6. But since we are in 2 dimensions, we have to consider all of the points where x is -6. So it's going to work out to be a vertical line that contains every point having an x coordinate of -6. So again, let's do some point plotting for this. So I'm drawing a table. We have x and y. And let's say if x is -6, y could be 0. If x is -6, y could be 2. If x is -6, y could be -4. Y could be anything. X is always -6 for the equation of x equal to -6. Let's plot these 3 points and then we'll draw our line. So again, starting from the origin, we go to the left, 6, 1, 2, 3, 4, 5, 6, and we'll plot our point there. Now for -6, 2, we have to go up 2, and for -6, -4, we have to go down 4. All right, draw your line in. So that line is the graph for x equal to -6. All right, so whenever you have x equal a constant, you're going to have a vertical line. And whenever you have y equal to some constant, you're going to have a horizontal line. So now you try, go ahead and graph the line x equals 5, and then graph the line y equals -2. Pause the video, and then we'll do this together. Okay, let's take a look at first x equal to 5. We already know x equal to 5 should be a horizontal line, right? So if you want to do this quickly, starting from the origin, if you count to the right, 1, 2, 3, 4, 5, you can plot a point there where x is equal to 5, but remember to draw the line, right? We're graphing in 2 dimensions, not 1 dimension. If you only put a point, you're just considering the 1-dimensional solution. We need the 2-dimensional one. Okay, all right. How about for y equals -2? Okay, starting from the origin, y equals -2. If I go down 1, 2, plot a point, that's just 1 point, but all of the points is going to be the horizontal line, and that contains all of the solutions for y equal to -2.